This is the work for some checkpoint problems in your packet. So first you should be able to do GFMs at this point, or gram per mole mass. You're looking each of these elements up on the periodic table. I'll show you the work for each of these. So this represents our 3 calciums, 2 phosphoruses, and 8 oxygens, and the mass of each of those from the periodic table. This comes out to be 310.18272 grams. Because of the number of sig figs right there, we're going to actually have to take off 272, and this will round very nicely to 310.18 grams. There should be a little dot right there on your sheet. I don't know if it's showing up on my smartboard though. So this is when we're doing a gram per mole mass for a hydrated compound, you have to keep in mind that dot just means you're adding the mass of those waters. So I'm going to kind of move this one down here a little bit. Zinc's mass is 65.409 plus our 2 chlorines times 35.453 each. We have 8 hydrogens, so 4 times 2. And remember, even though it looks, this really just means we're adding the water. We're not like multiplying it, like when you see a dot in math. And last but not least, sorry, I'm running out of a little room here. I have 4 times 1 oxygen, so I'm doing 4 times 15.9994. And this comes out to 208.37612 grams. Looking at my decimal places here, I have 2 numbers that have 3 decimal places in them, so that's what I'm going to be limited to. I can take off my 1, 2 right here. Oh, and I'm sorry, these are actually grams per mole, not grams. So because these are GFMs, that would be the number of grams you would have in 1 mole of this substance. When you convert between grams and moles, I'll put the answers up to these, and then if you need to see the work, I'll show that as well. So you can pause the video and try each of these problems. So we have our starting amount of 250 grams for KOH. I need grams on the bottom. I've calculated my gram formula mass to be 56.10569 grams per 1 mole. I want my grams on the bottom, so I'm actually dividing here. Because the way this is written, this is actually 2 sig figs, so once you divide these, you'll get 4.5 moles. 3.40 moles of NaCl. I calculated my gram formula mass to be 58.44277 grams per 1 mole. My moles are going to go away, so I'm actually multiplying here. I can have a total of 3 sig figs, so this rounded nicely to 199. So try your conversions between grams and molecules. Remember, this is involving 6.022 times 10 to the 22nd, or 10 to the 23rd, sorry. So you should have gotten 7.10 times 10 to the 23rd molecules for your first one. In order to calculate this one, just going to move this down a little bit. You start with your 221 grams, 187.558 grams in 1 mole. So that allows me to first get rid of my grams. My 187.558 is the, 5558, sorry, one more 5 in there, is the GFM for copper nitrate. I now need to get rid of moles, and I want to put that into molecules, so I'll put 1 mole on the bottom, and my molecules are going to go on top. So you're multiplying 221 times 6.022 times 10 to the 23rd. Remember, you're using that little e on your calculator, and then you're dividing it by 187.588, and that's going to give you 7.10 times 10 to the 23rd. For your uranium fluoride, should have gotten 199 grams. So strange. It turns out like the other one, but it does. So I'm going to start here with my starting number of molecules, which is 3.40 times 10 to the 21 molecules. I need to get rid of molecules in order to put this into grams. So that will turn my molecules into moles. Next, I need to get rid of moles. I'm going to use my GFM. 1 mole of uranium fluoride is 352.0194 grams. Moles are leaving. Multiply across the top and then divide by that 6.02 times 10 to the 23rd on the bottom, and you should get 199 grams. Each of these had 3 sig figs based on what you started with. Move some stuff down here. So your Avogadro's hypothesis, we're assuming STP on these, which is 1 mole is going to occupy 22.4 liters. You do also need a GFM calculation since you're going between liters and grams. So try each of these, pause the video, and then I'll put the answers up. So for the first one, you're taking your 71.68 liters. We need to get rid of liters. So our 22.4 liters to 1 mole is going to go right. Our 22.4 liters is going on the bottom, or 1 mole on top. To get rid of that mole, we're going to have 1 mole right here, 28.0134 grams. Moles are going to go away, so we're multiplying 71.68 times 28.0134. Divide that by 22.4, and you should get 89.64. 4 sig figs, so that's what we're showing in our answer. And then in the last one that you had to do, you're starting with 21.02 grams of N2. We're going to first use the GFM of nitrogen, which is 28.0134. Remember, it's N2, so you're actually multiplying the value on the periodic table by 2. That's going to give us 1 mole. Grams have gone away. We want our answer, according to the problem, to come out in liters. So we are going to turn our 1 mole into liters by putting moles on the bottom and our 22.4 on top. You get 4 sig figs again here based on that number. So 16.81 is your answer. You should be able to do sort of simple mole-mole relationships and more complicated gram-mole relationships based on a reaction. So both of these problems are utilizing the reaction of aluminum and oxygen to make aluminum oxide. So we want to know how many moles of aluminum are going to be required to produce 5 moles of aluminum oxide. And what you should get for this is, should come out to 10 moles of aluminum. So let's make sure you were able to get there okay. Our starting amount is 5.0 moles of aluminum oxide. We need aluminum oxide to go away. We're comparing that to aluminum. So we're going to now go to our reaction. We have 2 moles of aluminum oxide being equivalent to, we're going to compare that to aluminum, 4 moles of regular aluminum. So now our aluminum oxide moles are going to go away. Now we have aluminum up here, which is exactly what we want, and since we want our answer in moles of aluminum, we're good to go. 5 times 4 is 20, divided by 2 gives us 10. And we do need that decimal to give us the 3 sig figs based on our 5.0 moles. So next one we have grams, which is a little bit more complicated because you are going to have to do a GFM calculation. So I'm going to start, actually I'll put the answer up, I'll give you a minute to calculate it, put the answer up, so pause the video, see if you get what I get. You should get 331.36 grams of aluminum oxide. So we're going to start with our 175.37 grams of aluminum. In order to relate this to a reaction, we have to go into moles. So you're going to take your gram formula mass for aluminum, put the mass on the bottom, or the grams on the bottom. And it is great to identify moles of what substance you're talking about so you don't get confused. Same with grams. Those grams have gone away. Now we have our moles of aluminum, and we need to relate that to eventually grams of aluminum oxide, but we have to go through moles first. So we go back up to our reaction, and we have this ratio right here, 4 moles of aluminum to 2 moles of aluminum oxide. So I'm going to put my 4 moles of aluminum and my 2 moles of aluminum oxide in. My 4 moles of aluminum go away. Now I have moles of aluminum oxide. I want grams of aluminum oxide. So the last thing I'm going to do is take my moles, 1 mole of Al2O3, and then my gram formula mass for that is 101.96128 grams of Al2O3. Moles are canceling, so now I can multiply across the top, divide across the bottom, and you should get 331.36. Based on my first number right over here, I have 1, 2, 3, 4, 5 sig figs, so I kept 5 sig figs in my answer.